Hello everyone, welcome to my channel. Today I have some really exciting news to share with you all. OpenAI has recently launched their latest AI model and it's truly groundbreaking. I'm thrilled to take you through the details of this remarkable AI model called Shap.E. OpenAI, known for their cutting edge research in artificial intelligence, has once again pushed the boundaries of what's possible in the field. Let's start by discussing the paper. OpenAI has published an extensive paper that outlines the inner workings and advancements of this model. While it may delve into technical aspects, don't worry, I'll break it down into digestible pieces for you. New OpenAI model is called Shap.E, generating conditional 3D implicit functions. It is a conditional generative model for 3D assets. Shape directly generates the parameters of implicit functions that can be rendered as both textured meshes and neural radiance fields. It takes text as an input and outputs a corresponding 3D image. When trained on a large data set of paired 3D and text data, resulting models are capable of generating complex and diverse 3D assets in the matter of seconds. Let us see some examples of the model. So if you give text as a penguin, it will generate a 3D image that shows a penguin on the screen. A chair that looks like an avocado, you will get this result as a 3D image. An airplane that looks like a banana, this is the result. It's quite impressive, right? So there's an important concept involved here called Nerf, which is a neural radiance field. They've also defined it over here. So a neural radiance field nerve represents a 3D scene as a function mapping coordinates and viewing directions to densities and RGB colors. Let me quickly go to the Nerf paper that was also published in early 2020. Nerf utilizes a deep neural network to model the neural radiance fields. The network takes a 3D spatial position as input and outputs the corresponding color and density of the scene at that position. The neural network is trained using a large data set of images and corresponding camera poses. During training, the network learns to predict the radiance and density values that best reconstruct the input images. It takes 5D coordinate, which includes spatial location, X, Y, Z, and viewing direction, and it outputs the volume density and view dependent emitted radiance at that spatial location. So let us go and check the few examples or outputs that Nerve can produce. You see that this is a 3D view of the given images, right? So this is an output produced by Nerve. There are a lot of sample examples on this uh, website, right? There is also code available, paper we have discussed briefly just now. So this is quite impressive work that was done in 2020. Now what Shape E is doing is it is utilizing that nerve and also combining the training model in such a way that the training model includes 3D images and corresponding text so that model can learn the meaning behind a 3D image that was provided in the training set and give the results in the best possible way as we see in the few of these examples. Now let us take some time and take a look at the code. OpenAI has generously made the code for this model available on GitHub, making it accessible even to those without extensive AI programming knowledge. Code. So this is the GitHub, which is provided by OpenAI. This is for the Shap.E, and this can easily be cloned. And the README contains the proper guidance of how to use this particular model, and you can also run it on your local machine. So this is the GitHub link. It will also be shared in my YouTube link below. Also, this is the GitHub where it contains three. If you see, three notebooks are present over here, which is sample text to 3D, sample image to 3D, and code model, right? So sample text to 3D converts a text prompt into a 3D image. This particular notebook converts a synthetic image into a 3D model, right? And this is for generating the meshes of the model. So let us discuss generating a 3D model condition on a text prompt. So in this particular video, we'll be discussing about this notebook, and in my further videos, we will also discuss each of the other two notebooks in details. What I have done is, so I have also been working with the model in my own notebook, and I want to show you some of the results I have been able to achieve. I'm using Google Colab to run the model. You're free to use your local machine. You can run it on a GPU or CPU. So if you see, this is the notebook that I have made on Colab so that I can run it on a GPU that can train the model in a faster way. But obviously, you're open to use CPU as well. So quickly, let's dive into what Shape.E code looks like. You just need to clone this, right? Once you clone the GitHub repository, go to the directory called Shape.E. In the directory, you need to install all the packages that is required for running this particular model. And then in the next cell, you need to uh, take or import all the important packages that is needed to run this model. You specify the device, whether you're using CUDA if you have GPU available, else you can also specify CPU. You load the model, and then there is another cell wherein you say what prompt you want to give, right? So in this case, a text is the input and output will be a 3D image. So what I say is I provide a prompt saying generate or rather a blue elephant, right? So when I give a text called a blue elephant, there will be the latents and generated by this uh, pro, by using this prompt. And if you see this result of our this particular prompt is in the next cell, right? So we've asked it to generate a blue elephant, and it generates a 3D image of blue elephant. If you see, and if you've noticed, this is the render mode, which is Nerf, right? We've discussed Nerf. So Nerf was used to render these results that we see on the screen, right? You can also save these outputs in the location wherever you want. So this is a pretty straightforward code that was available to just demonstrate what capabilities this Shapey model has. In conclusion, OpenAI's latest AI model represents a significant leap forward in the field, right? The potential applications and impact this technology can have uh, are immense. It's an exciting time for AI enthusiasts and researchers alike. If you found this video informative and want to stay updated on the latest advancements in AI and technology, don't forget to hit that like button and subscribe to my channel. Join our community as we explore the frontiers of innovation together. Thank you for tuning in today. Remember, the future is bright, and with each step we take, we are moving closer to a world where AI transforms our lives in unimaginable ways. Until next time, take care and keep exploring.